Section 4.4, Additional Equations and Inequalities. Okay, let's first talk about the radical equations, or equations involving rational powers, as they're sometimes called. As you can see on the screen, I have a picture of a beta fish and of Tom and Jerry. Sometimes these equations are referred to as the beta fish of equations or the Tom and Jerry of equations. Tom and Jerry was a cartoon, if you've never seen it, where the cat, Tom, tried to get the mouse Jerry so he could eat them. And most episodes they were butting heads, going head to head, trying for the cat to get the mouse, but occasionally they would team up if a third element came on. Beta fish are on here. If you've ever owned a beta fish, it's one of the simplest fish and easiest fish to own, simply because they like dirty water and they live in dirty water, so you don't have to clean their tank obsessively. But the beta fish are also known as fighting fish, and so two male beta fish will fight each other to the death if they get into the same tank. And sometimes beta fish will also fight other fish. Just depends on the attitude of the beta fish itself, but it can happen. And so when we see a radical and a number in the problem, we want to separate the radical and the number. Why? Because the radical and the number are the Tom and Jerry or the beta fish of things. We don't want two radicals on the same side. We don't want a radical and a number on the same side if we can avoid it. We don't want to have that kind of blood on our hands to keep away from it. So if we look at example 1 on page 287, we're going to see that we have a radical on the left, as in the radical x plus 5, the square root of x plus 5, and then plus 1, that's on the outside of that particular function, equal to x. And we're being asked to solve this. So the first thing we have to do is we have to move this 1. It has to go away. It's on the same side as this square root of x plus 5. This is the beta fish, and it's saying, I don't like other fish. And we say, okay, well, we got to get it in its own tank. You know, sometimes beta fish do get along, but we once had a beta fish and decided to maybe integrate with some other fish that we had, and we knew that beta fish can be fighting fish, so I had the fish in a little baggie, and I put the baggie into the water, thinking that maybe this beta would get along with the other fish that were in the tank. Unfortunately, it started hitting the outside of the baggie immediately upon getting into the bigger tank, trying to get to the other fish to kill them. So that didn't work out. Thankfully, we still had it in a baggie, and we just put it back in its own tank. So we need to move this 1 over so this problem can be solved. And so that's what we'll do, is we'll take it and move it over. We'll leave the x plus 5 here on the left where it's at. We'll leave the x where it was at, and we bring this 1 over. It becomes minus 1. And now everybody's happy. There's going to be no killing in this problem. Not that we condone killing at all. We definitely don't. But definitely no bloodshed in this problem between radicals and numbers. I mean, that's not pretty to see if you've ever seen it. I know I've seen it. Radicals can be a little brutal sometimes. I'm kidding, of course. All right, so now we go to solve this thing. To solve it, we're going to have to square both sides to make this work, because it's the only way to get rid of this radical here is to square. But we can't just do it to one side. Remember, algebra operations demand that what we do on one side, we do to the other side. And so we're going to square both sides of this thing. And squaring the left is easy. What's in the radical comes right on out, so it becomes x plus 5. That's great. On the other side, though, not quite as good, because this is a FOIL that has to happen. So the f in FOIL is x times x, which is going to be x squared. Then you have the outside, which is x times 1. It's going to be minus x. The inside is negative 1 times x. That's going to be a minus x again. And finally, last is negative 1 times negative 1, or plus 1. That's going to give us x plus 5 equal to x squared minus 2x plus 1. Now, it's good, probably a point here we need to bring this up. When we square both sides, we have a potential here for some chaos to happen. And that is, if you remember this, a negative value squared gives us a positive number, and a positive number squared also gives us a positive number. By us squaring, what it does is it forces us to check the answer at the end, because we may have just created a false positive with the work that we're doing. Now, the only way to solve with a radical is to square both sides. But once we've squared, what it does do is commit us to check the answer. So I'm going to put a big check mark here to remind myself at the end, make sure you check the answer or answers if there's multiple answers, to make sure that those are good answers. I can't just assume. I can't just say, hey, this is the good answer. Let me go to the back of the book and verify that these are the answers. No, I actually have to physically check the answers that I get to ensure that my squaring didn't alter what should have happened here. Back to the regular problem here. We've got x squared minus 2x plus 1 on the right. We've got x plus 5 on the left. Let's make it equal 0, because when it equals 0, we can solve quadratics a heck of a lot easier, especially because this is a quadratic. So we're going to say 0 equals x squared minus 2x plus 1. And we're going to bring over the other x, that's minus x, and bring over the 5, that's going to be minus 5. Let's consolidate down here so that 0 equals x squared. Nothing is touching that, but we have a minus 2x and a minus x. That's going to be minus 3x. And we have a positive 1 and a negative 5. That's going to make minus 4. All right, let's see if this is factorable. I believe it is, because the factors of 4 are 4 and 1, and 4 and 1 together will make 3, especially if we subtract or add to a negative one of those values. So I believe we can say that this instead equals x minus 4 and x plus 1. That should give us what we need for this and allow us to solve for this problem, because what it says is 0 equals x minus 4 and x plus 1, meaning that x minus 4 equals 0 and x plus 1 equals 0. If we move the 4 to the right, that's going to have x equals 4. If we move this 1 to the right, that's going to be x equals negative 1. And so we have two answers. We have x equals 4 and we have x equals negative 1. And so now our job is to ensure that both of these answers are good, or at least one of these answers is good. Because right now there's two answers that we found and there's three scenarios that we've created. Scenario 1, both of these are legitimate answers. Scenario number 2, one of these two answers is legitimate. Scenario number 3, neither of these answers is legitimate, thanks to the squaring work that we had to do in order to solve it. So now we have to check it. So we're going to go back to the original problem right here, and we're going to put in first 4 for x and see if we get a true statement, and then we'll put in negative 1 for x and see if we get a true statement. All right, so let's use 4 first. So the original was x plus 5, so in our case we're going to have the square root of 4 plus 5. And then there was a plus 1 on the outside, and it equaled x, except in our case it's going to equal 4. Well, 4 plus 5 is 9, and the square root of 9 is going to be 3, and 3 plus 1 does indeed equal 4. So I know that this checks out. I'm going to go ahead and circle this one and say, yep, that checks out just fine. We're good to go there. Let's check out negative 1. Let's go over here where we have some space for negative 1, and again it was the square root of, except this time negative 1 instead of x plus 5. Then there was a plus 1 on the outside, and it's going to equal negative 1. All right, negative 1 plus 5 is 4. So we have the square root of 4 plus 1 equals negative 1. And square root of 4 is 2. And 2 plus 1 does not equal negative 1. You know, 3 does not equal negative 1. And so right off the bat, we found an answer that doesn't work. Our squaring gave us this negative 1, but when we checked it, it wasn't an actual answer. And so what we can say is with confidence now that x equals 4 is the answer to this problem, not the one that we found, or negative 1 that we found here after we checked it. So again, doubly reason why you have to check the answers, because what answers you get may or may not work. Now let's pretend for a moment that neither answer was the answer. Does this thing have an answer then? Yes, of course it does. The answer would be the null set.